Assalamualaikum warahmatullahi wabarakatuh. Okay, today we are going to learn about extremum of function. So to find the critical value, we need to make the first partial derivative, and to find the critical point, we need to make the first partial derivative equal to 0. And to determine the nature of the critical point, we need to make the second partial derivative test. We need to make let d equal to fxx multiply fyy minus fxy square. So if the d is more than 0 and fxx is more than 0, the critical point is minimum point. And if d more than 0 and fxx is less than 0, the critical point is maximum point. If the d less than 0, it is a saddle point, and if d equal to 0, it is no conclusion, mean not maximum, not minimum, or saddle point. Okay, now let's move to tutorial 29 number 6. So the questions given, fxy equal to 3y cubed minus 3x power of 4 minus 6x squared y plus 1 per 16. So we need to find the critical point and the nature of the critical point. The nature of the critical point means we need to determine the critical point is a maximum, minimum, saddle point, or no conclusion. So first of all, we need to list down all the first partial derivative and the second partial derivative for this function. So we need to find out fx, fy, fxx, fyy, and fxy that equal to fyx. So let's find out the fx. Our fx will be negative 12x cubed minus 12xy, and our fy equal to 6y cubed minus 6x cubed, and our fxx will be equal to negative 36x squared minus 12y, and our fyy equal to 12y, and fxy equal to negative 12x. So to find the critical value or critical point, we need to make the first derivative equal to 0. So this one, this both we need to equal to 0, and make the s1, this s2, because we have two unknown here. So you have to choose either 1 or 2, and I will use 2. So from 2, 6y squared minus 6x squared equal to 0. We will get like this. Okay, so here our y value is x and negative x. After we get the value of y, we need to substitute this to others one. So mean in f x that we not choose, and negative 2xy equal to 0. So when our y equal to x, will be like 12x cubed negative 12x, okay, equal to 0, and negative 12x minus. Okay, this we will get because we factorize the x square from here's and here's. So by that, our x will be equal to 0 and -1. So because of x equal to y equal to x, so our point will be like this: 0, 0, and -1, -1. And we also need to find when y equal to negative x. We will get like negative 12x cubed minus 12x squared equal to 0. So x cubed negative x plus 12 equal to 0. This also like previous, we will factor this one and get this one. So our x will be get 0 and 1. So our point, we need to determine our point. So when y equal to x, our point is 0, 0 and -1, -1. So here we get 0, 0 and 1, -1. So with all the point that we get, we need to determine the nature. So we have to make the table. So after we make the table like this, we need to find the value for our fxx, our fyy, and our fxy square. So we just need to substitute the x and y value based on our point. So like this point 0, 0 at this at fxx, the x must be 0 and the y of also 0. So after we find the value of x, fyy, and fxy square, we have to substitute the value following this formula to determine the d. So it refer to this formula, we need to multiply this term and minus like this. So following to this formula, we need to multiply this one and minus this one. So we be like this. So 0 minus 0 will be 0 and minus 0. So that's why the d equal to 0. Same goes with this one, negative 24 minus multiply negative 12 and minus negative 12, we will get 144. So after we get the d value, we need to refer this table to find the conclusion. So here, when the 0.00 d equal to 0, that means the critical point is no conclusion. And for the second point, 1, -1, we will get d equal to 144, that more than 0, and the fxx less than 0. So it following this 1. So the critical point is maximum. Same goes to this one. So this is our conclusion. So in final result, we only look to this one. Okay, so 0, 0 is a non-conclusion, and 1, negative 1 is a maximum point, negative 1 and negative 1 is a maximum point.
Now I'm going to explain experiment of function for tutorial 29, number 21. So given that f x y equals to 2x cubed plus 2y cubed minus 12xy plus 1, and then find the critical points to determine the relative maximum, relative minimum, or saddle point if any. So the first thing we need to find critical points. So first step, we need to find fx equals to 6x squared minus 12y equals to 0. Number 2, we need to find fy equals to 6y squared minus 12x equals to 0. This is number 2. Then we need to find fxx, which is 12x. Then fyy, which is 12y. Now we need to find fxy. Remember that fxy equals to is the same as fyx. I just want to take the fx. Fx equals to 6x squared minus 12y. So fxy, we differentiate the y, we get negative 12. Now from the equation 2, we know that 6y squared minus 12x equals to 0. Negative 12x equals to negative 6y squared. X equals to negative 6y squared over negative 12. So x equals to y squared over 2. When x equals to y squared over 2, from equation 1, we get this one, 6x squared minus 12y. 6x squared minus 12y equals to 0. So just substitute this one into this one. So we will get 6y squared over 2 square minus 12y equals to 0. Then we will get 6y 4 over 4 minus 12y equals to 0, 2, 3. So we will get 3y 4 over 2 minus 12y equals to 0. And then y equals to 3 over 2 y cubed minus 12 equals to 0. So first, we know that we get y equals to 0, and another one, we will get 3 over 2 y cubed minus 12 equals to 0. 3 over 2 y cubed equals to 12. 3y cubed equals to 24. Y cubed equals to 8. Y equals to 2. So we know that the value of y equals to 0 and y equals to 2. So, hence, we know that x equals to y squared over 2, right? So, just substitute the value of y in x. X equals to y squared over 2. When y equals to 0, x equals to 0 squared over 2 equals to 0. When y equals to 2, x equals to 2 squared over 2, 4 over 2 equals to 2. So we know that the critical points we get is 0, 0 and 2, 2 critical points. Now we already know that critical points is 0, 0 and 2, 2. Now we want to determine whether this critical points is maximum point, minimum point or saddle point. Just look at this, fxx, we know that fxx is 12x, so just substitute. This one is x, this one is the value of y, so 12x multiplied by 0 equals to 0. Now we want fyy. Fyy, we know that it is 12y, so substitute the value of y 0 into this one, so we will get 12 multiplied by 0, we will get 0. And fxy, we know it is negative 12, so just take it there, negative 12 square. The same goes as the second point, which is 2, 2. So substitute this value into this one, we will get 12 minus 2, 12 multiplied by 2, 12 times 2 equals to 24, 12 times 2 equals to 24. This is the same, negative 12 square. To determine whether it is maximum, minimum or saddle point, we need to use let t equals to fxx times fyy minus fxy square. So we for the first point first, which is 0, 0. So fxx, we know that it is 0, 0 times 0 fyy minus fxy negative 12 square. We will get d equals to negative 144. So we know that the value is less than 0. So when less than the 0, we know that it is saddle point. For the second point, which 2, 2, d equals to 24 times 24 minus negative 12 square. We will get 576 minus 144 equals to 432. So d equals to 432. We know that d is greater than 0, and for this point fxx equals to 24, right? Fxx equals to 24. So, and f as x greater than 0, so we know that it is a minimum point. So that's it.
Okay, now we move to quiz question, which is our group will represent question 3. So, given that fxy equal to 2x cubed minus xy square plus x square minus y square plus 3, find the critical points and determine the nature of the point. So the nature of the point is whether the point is maximum, minimum, saddle point, or no conclusion. So in order to get this, we need to find fx, fy, fxx, fyy, and fxy, which is equal to fyx. So for your information, fx is the first partial derivative, which is 6x square minus y square plus 2x, which is equation 1, and fy is negative 2xy minus 2y, which is second equation. So fxx is the second partial derivative. So we got 12x plus 2. fyy is negative 2x minus 2, and fyx or fxy is negative 2y. So we need to find the value of x and y. So I choose from equation 2. I take which is equation 2, which is fy equal to negative 2xy minus 2y is equal to 0. Okay, remember, this is must equal to 0 because we need to get the value. So I make the factorization of this equation. We get negative 2y x plus 1 equal to 0. So x equal to negative 1 and y equal to 0. So after this, we need to find the coordinate of the critical point. We need to find the coordinate for this critical to find the critical point. So I made the equation from, I substitute what I have. I substitute this value to equation 1 from 1 when x equal to negative 1. When x equal to negative 1, we got 6 minus y square minus 2 equal to 0. 4 equal to y square. So when we square root y square to 4, we got plus minus 2, which is y. Okay, we get this value of y, this coordinate of y. Okay, when y is equal to 0, 6x square plus 2x is equal to 0. So I factorize this, I get x 6x plus 2 is equal to 0, 6x is equal to negative 2, and I get x is equal to negative 1 over 3 and 0. So from these two values we can find the coordinate, which is negative 1 over 3, 0 and 0, 0. So okay, after this we need to transfer this equation. Okay, no, wait. Okay, then from when x is equal to 1, we get the coordinate of negative 1, 2 and negative 1, negative 2. Okay, from these four coordinate, we need to transfer this to this table, which is okay. This is I have done for you guys. So we substitute this fx, the value of the critical point, 4 value of critical point. We substitute the value of y and x to fxx that we have done. So I get all these value. So when we substitute the 2 to fy for the first one, I get 0, and same like others. Okay, we look at this formula. We need to find d. In order to find d, I need to multiply this, multiply all of this, and minus. So I get the value of d. So when you get the value of d, you need to refer to this. We need to refer to this table. When I refer to this table, we can make the conclusion when d is less than 0, the conclusion is saddle point. When the conclusion is saddle point. When d is greater than 0 but fxx is less than 0, we can find the maximum point. And when d is less than 0, we can find the saddle point. So yeah, that's all. Thank you.